Hello everyone. In this video we are going to learn about the combinations. What are combinations? What is the difference between the permutations and combinations? And what are some of the formally based on combinations and how to apply them? We will learn with some of the examples. We have already learnt about the permutations in the previous videos. What was permutation? Permutation actually is the arrangement of some or all objects. But when we are arranging some of the objects, we have to select them first. But when we are selecting them, then the order of the objects is immaterial. So selection is also one of the important part of arranging or selecting some of the objects. Here we can think of one of the example here. Suppose we have four numbers 1, 2, 3, 4 and we want to select any three of them. Then these three can be taken as either 1, 2, 3 or 1, 2, 4 or 1, 3, 4 or 2, 3 and 4. Here the order of them is immaterial. So we are taking only one order. That's what is the combination. Also we can say that how many different groups of three objects can be made from these four. So these are four groups we can make. It means when we define the combination, we can define it like this, that the number of different selections of some or all objects is combination, but here the order is immaterial. Or also we can define it as how many different number of groups taking some or all objects can be made, that is combinations, and here also the order is immaterial. So this is the way we can understand the difference between the permutation and combination. Then when we are arranging some or all objects, that is permutations. But when we are selecting the objects, then it is combination. Then how to represent it? When we want to represent the permutations, there is a second difference. We can say representation of this was NPR, or we said this as PNR when we were arranging R objects out of N. But when we go for combination, there is selections of R objects out of N, that is represented as NCR, or we can say CNR. Here we have to mind one thing, that R is always to be less than or equal to N. Because if we want to select all objects, then that will be NCN or CNN. And that you can very well understand, it will be always equal to 1, because when we want to select all the objects, then it is only one way. Now we will learn how to calculate the value of NCR, that is number of combinations or number of selections of R objects out of N objects. We are finding the value of combinations of R objects out of N objects. What we have to do? We know when we want to find out the permutations, NPR. NPR. NPR means what? Arranging R objects out of N. Do we know that when we want to arrange R objects, first we have to select them? It means here we have to make two operations. One is selecting R objects and the second is to arrange those R objects. So here we can say that NPR is equal to selection of R objects and then their arrangement. Selections of R objects. Just now we are represented as NCR or CNR. This is NCR. How to arrange R objects out of R? That will be given by RPR. we know that RPR is factorial R. We have already learnt in the previous videos. Can we say here that NPR is equal to NCR into factorial R gives us a relation between the permutations and combinations? And from this only we can calculate the value of NCR, that is NPR upon factorial R. NPR we know is factorial N upon factorial N minus R divided by factorial R, which is equal to factorial N upon factorial R into factorial N minus R. So this becomes the formula to calculate NCR. Now applying this formula, suppose we want to find out NCN, selection of all n objects. As I told you just now, it is 1. But how it is applying this formula also we can see. NCN means here R is also n. Can we say it will be factorial n upon factorial n into factorial n minus n? This factorial n cancels this. And this is coming as 1 upon factorial 0. And we know factorial 0 is 1. This also we have learnt in the previous video. So it is 1 upon 1, or we can say 1. So from the formula also we can calculate that NCN is 1. Logically we have learnt it just now that we are selecting all n means there is only one way. Now how to calculate the value? Suppose we want to find out the value of 8C3. Here R is 3 and n is 8. Applying this formula, can we write factorial 8 upon factorial 3 into factorial 8 minus 3? Which gives us 8 into 7 into 6 into factorial 5 upon factorial 3 into factorial 5. We know how to reduce it to this. This factorial 5 and factorial 5 cancel. See, learn a good thing here. We have learned that NCR is equal to NPR upon factorial R. In case we want to find out the value of 8P3, we have learned we can directly multiply the three numbers starting from 8, that is 8 into 7 into 6, and here comes divided by factorial 3. As many is the value of R, that many numbers starting from the value of n we take and divide by the value of factorial R. Is it equal to 8 into 7 into 6 upon 6? 6 cancels, this comes as 56. Like this we can find out the value of NCR for any value of n or R. We can learn now one of the property of the formula NCR. This is equal to NCN minus R. How to prove it? We know that NCR is same as factorial n upon factorial R into factorial n minus R. Just now we have learnt. If we go to the right hand side, here we find that R is same as n minus R. If we apply this formula in this, will we get factorial n upon factorial n minus R, that is R, into factorial n minus R. Simplifying, we are getting factorial n upon factorial n minus R into factorial n minus n plus R, n and n cancel. So this gives us factorial n upon factorial n minus R into factorial R. Is it same as NCR? This is equal to NCR, which is the left hand side. So we can say that NCR is same as NCR minus R. Where to apply it? Suppose we want to find out the value of 8C5. Here what we find? That this R is 5, which is more than half of 8. To make the calculations a bit easy, we can also write this as 8C8 minus 5, which is 8C3, and we have just understood how to find out the value of 8C3, that is equal to 56. So anyway we are finding that this is more than half of n, then we can apply this as a formula to calculate. Based on the same, we have one more property, that NCX is equal to NCY implies that x plus y is equal to n. How to prove it? So we have just now learnt that NCR is same as NCN minus R. From this, if we have NCX is equal to NCY, can we write this as NCX is equal to NCN minus Y? And as this and this are to be equal, both are R. Can we say then that x is equal to n minus y? Or we can write that x plus y is equal to n. That is the proof of this. Based on this, suppose you are given a problem, if 8c5 is same as 8cx, find the value of x. What we will do? We can apply this property here and we can write that x plus 5 will be equal to 8. It means x is equal to 8 minus 5, that is 3. One more property of the combinations we have, that in case we have NCR minus 1 plus NCR, that is same as n plus 1 CR. And very easily you can prove it by applying the values of NCR and all. Based on this, suppose you have been given somewhere 8c5 plus 8c6. What is the value of this? You can see here very well that r minus 1 is 5. R minus 1 is 5 and r is equal to 6. And n is here, that is 8. If we apply the formula here, that is n plus 1 CR, then we find this will be 8 plus 1 C 6, or we can say 9C6. Like this we can calculate the value of this type of function. Now let's take some of the examples based on combinations. First one here is, how many straight lines can be formed from the 21 points which lie on the circumference of a circle. When we have the points on the circumference of a circle, we can very well see that no points are collinear of them. No 3 points are collinear, we can say. And it means total number of points when we talk about is 21. We know that to draw a line we need 2 points. If we join any 2 points, then straight line is formed. So we can write, for a straight line, 2 points are to be joined. It means what? How many groups of 2 points from 21 can be formed? That many straight lines can be formed. Or we can say how many selections of 2 points can be formed from 21? That many straight lines can be formed. So we can say it means number of straight lines will be equal to selection of or groups of 2 points from 21. Is it equal to 21C2? And we know how to calculate 21C2. Directly we can do it by 21 into 20 upon factorial 2, NPR upon factorial R. And this gives us 210. Because 2 cancels this 20 by 10 times, 21 into 10 is 210. It means 210 straight lines can be formed by joining these 21 points which are lying on the circumference of a circle. Sometimes we are given some of the restrictions in the problems of combinations also. Here we will take some of the example, and with that we will understand if this type of particular restrictions are given, how to apply that, and we can also convert them into the formula. See, the example is, in how many ways a team of cricket can be selected from 17 players if number 1, 2 particular players are always taken, and number 2 is 2 particular players are never taken. How to solve this? See, when the case comes, total number of players we have is 17. How many are required for a team? Required for a team, that is 11. We know that 11 players are there in a team of cricket. Now, in the first case, we have been given that 2 particular players are always taken. In the first case, 2 particular players are always taken. You can see when 2 players are already taken, it means we have to select only 9. Out of what? Out of 15, because from 17 that 2 have been already taken out. So we are taking when 2 players are always taken, then we are to select only 11 minus 2, that is 9, from 17 minus 2, that is 15. And that can be done as 15C9. It means we can say, therefore, number of different teams or number of ways the team can be formed will be equal to how much? That is 15C9. And 15C9 can be written as 15C, 15 minus 9, that is 15C6, and we can calculate and find out the value. From this we can make a formula. If m objects are always taken from n, then the number of ways or number of selections will be given by n minus m CR minus n. Suppose we want to select R objects out of n and m are always taken, then we can apply this the formula n minus m CR minus n. Like here, we can write here 17 minus 2C 11 minus 2. It's a shortcut. We can apply this to directly get the answer. We can apply this to get the answer directly. In second case, we have been given 2 particular players are never taken. Never taken means what? Those 2 players are already out from the 17. It means we have to take all 11 from the remaining 15 only. So we can say the number of ways to select team will be equal to 17 minus 2 C 11 or not. Because all 11 are to be selected from the remaining one, because that 2 are already out. And this will be same as 15 C 11, which can be written as 15 C 4, and we can calculate and find the answer. For such case also we can make a formula. If m are never taken from n, then to select R, the number of ways will be n minus MCR. So we can remember the two formulae here, which can be applied directly to the problem. If M objects are always taken, then the selections of R objects can be done by this as a formula, that is n minus MCR minus M. But if M are never taken, then the selection of R will be n minus MCR, because the remaining n minus M objects are to be taken, from which we have to select R objects. So we have understood the important formulae and the concept of the combination in this particular video. In the next video, we will be learning about the dictionary arrangements. Means how to arrange the letters of the given word in dictionary order. What is dictionary order and how to arrange them, and how to find out the rank of a particular word when we arrange them in the dictionary order. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.